The second types of OS implementation is monitors. So monitors is a programming language that which provide the functionality to that of semaphore and is easier to control. So we can actually having the idea of semaphore in monitor. So monitor is where we compile all the function of critical section in one place. Okay, compared like we have semaphore, each time we have critical section, we need to have the same weight, same signal, same weight, same signal together. But in monitor, we collect all the function that considered as critical section at one place. So look at the characteristic. Local data variable are accessible only by the monitor's procedure and not by any external procedure. So we have one procedures, okay, for monitor where other procedure mean other function cannot access but must be accessed by the monitor procedure. Okay, process enter monitor by invoking one of its procedure of the monitor, and only one process may be executing in the monitor at a time. Okay, so it's able to synchronize. Monitor supports synchronization by use of condition variables that are contained within the monitor and accessible only within the monitor. So it's only in the monitor. Okay, so we have C wait and C signal, where C wait suspend the execution, C signal to resume the execution of process. So the idea is similar with the same weight and same signal. So this is the structure of a monitor. So we have all procedure that considered as critical section and put it in one place known as monitor procedure. So new process will come and queue here to use the monitor. Okay, based on the condition, so it will then pass to which condition or which procedure to be used. So we have the C wait, okay, C wait for each of the condition, and C signal to bring back the process into the monitor. So this is kind of to reduce scattered semaphore in the whole big source code. So it's like we have that like kind of modular design where we put all the critical section procedure in one place. Okay, so this is the idea of having monitor. So this is solution. I think that one we really no need to go into details as long as you get the idea what is the monitor. Let's compare what we have in semaphore and monitor. Semaphore are mission independent because they are implemented in the kernel services. Okay, where we have the interruption, everything is managed by the kernel. And also semaphore permits more than one thread to access the critical section. Okay, because we have more than one semaphore scattered into the whole source code. Okay, unlike monitor, okay, but monitor is easier to implement because we have it one place. Okay, so mutual exclusion is monitor is automatic because what we have is all controlled by the monitor procedure, while using semaphore you need to do it manually. Okay, monitor can overcome the timing error, okay, because everything in one place, and also shared variable that are global to all processes in the monitor. Okay, So all process can having the shared variable together, while shared variable in semaphore is hidden because we do it in different area of the source code. Okay, the third type of enforcing mutual exclusion under operating system approach is message passing. Okay, it's when process interact with one another using two fundamental requirements that must be satisfied, which are synchronization and communication. As we know, synchronization is to enforce mutual exclusion, where we have multiple processes execute concurrently. And the other one is communication, where process need to exchange information with each other. So in message passing, we have one approach that providing two function, okay, especially that works in distributed system and also shared memory, multiprocessor, and uniprocessor system as well. So message passing, the primitive way is where we have send and receive. Okay, send, we need to provide where is the destination and also together with the message. Receive, where you need to put down the source and also the message. Okay, so a process send information in the form of a message to another process designated by a destination. So this is common. I think when you read it, you can easily absorb what does it mean by this explanation. A process receives information by executing the receive primitive, indicating the source and also the message, okay, that being passed. So this is the design characteristic of message system, where we have for synchronization what we want to have the send, receive, and addressing. We need to know the addressing of the sender and also receiver, and this is the format of the message itself, and also the queuing, whether to use first in first out or priority. So this is not that really important, but as long as you know the concept of message passing. So synchronization, where we need to synchronize between sender and also receiver. The receiver cannot receive message until it's sent by another process. So if there is no synchronization, might happen that the process waiting for something that is not sending to him. Okay, while when a receive primitive is executing in a process, there are two possibilities. Okay, if there is no waiting message, the process is blocked until a message arrives or a process continues to execute, abandoning the attempt to receive. Okay, so this is if no message arrives. If a message has previously been sent, the message is received and execution continues. So there is two possibility. One is waiting, another one is already sent. Okay, so blocking send, blocking receive. So both sender and receiver are blocked until the message is delivered. So that will control. There is no other activity until it's finished. Then we can go for another activity. Okay, so allows for tight synchronization between processes. It also sometimes referred to as a rendezvous, which means that it's being mutually agreed between sender and also receiver. Alright, let's see the situation for non-blocking send. Okay, so non-blocking send and blocking receive. Sender continues, but on receiver is blocked until the requested message arrive. Okay, it's considered as most useful combination because normally we are waiting for the message to arrive so that receiver can get the message. Okay, so example, a service process that exists to provide a service or resource to other processes. Okay, so send, no, non-blocking to send, but receive we block, okay, until the requested message arrive. On the other hand, non-blocking send and non-blocking receive, so neither party is required to wait. You can just send and receive without need to wait for each other. So what is addressing? So where to basically send the message so that the process can access the message or retrieve the message. Okay, so we have two categories: direct addressing and also indirect addressing. So just now we see that there are two types of addressing, indirect and direct. Direct addressing is where we put the specific identifier of the destination process. So we make it like explicit, design it to a sending process. So basically it's one-to-one communication. Okay, so we have the sender and also a receiver. So for the second one is indirect addressing, where also we could have one-to-one communication and also many-to-one or many-to-many. So like indirect addressing, we have one mailbox that the sender will send to the mailbox and the receiver will take out the message from the mailbox. So this could be accessed by more than one process. If we go to the next figure, let's show you the one-to-one where we have the mailbox. We could also use port. The concept is now it is the indirect communication. Okay, so we could have used indirect type of addressing. Lastly, let's look at the summary. So we have go through the mutual exclusion software approach for Deckers and Peterson's algorithm, just to make sure you get the idea of how mutual exclusion is being enforced using software approaches. And then we have all the term. Okay, for example, we have rest condition, what is OS concern, the process interaction, we have 3, and requirement for mutual exclusion, we have 6 in total. Right. For hardware support, we have 2, interrupt disabling and also the special machine instruction. Okay, and semaphore is one type in OS, monitor is second type in OS approach, and message passing is the third approach in OS. Okay, so I think we finished with the topic. So if you have any question, you can just directly ask to your lecturer. So that's all for now. Thank you everyone for listening, and bye.